think we're good. I'll look at the attendance. Everyone here now. Country is just going to be this. Nobody in the physical classroom. Yeah, give it some. All right. Can you guys hear me? Pretty good? No? No, I'm going to use the webcam. I'm going to use another device. Is it better now? Okay, yeah. So I think it was the webcam I was using as the audio. Now I changed it to yeah. Now I changed it to the laptop. So I'm hoping the laptop will pick up my audio much better than the webcam. All right, cool. All right. So how's the assignment going on? How's it going? Done? Something? Yeah, a lot of assignments piling up. So everybody uses, of course, as they want to delay submission. So like I said, I don't have deadlines per se, but when I give that out to the marker, I wouldn't want to have it delayed because given a delay, they're going to get it marked late. All right. Well, then you should be fine if you work on it today, tomorrow, even Saturday's deadline is on Saturday night or something like that. So yeah, fine. Not too hard. I think most people had some more diagnostics problems when they're testing stuff. I think that's the problem. But other than that, everything seems to be straightforward. Right. So there's assignment. I just put out a multiple choice quiz test. A practice multiple choice for the quiz for I think it's next week. Right. In person. You have to be in person. It's in your lab. So those who can't make it, well, we'll see what happens. Stuff. Absent, that's a 25 or 20%, 25%. Yeah, that's a 20%, I think. The lab exam is 25%. So that's going to be the lab too. So you have to make sure you make that. And then the group project is 35%. For the lab, well, right, so that's stuff. So practice the quiz. Now, the quiz is not everything. It doesn't cover all the topics. The sample one I did. Right, so that's just for you to get an idea of all the different the questions are going to come, the style and stuff. But the actual exam quiz will be different. Well, not as much different. It'll actually look like what you have there, but just will have other additional topics that you're studying. So something in your natural. Yeah, you should be good. So based on that, you can see how good you can answer it. Right, try to I don't know how you want to do it. How you want to take the quiz, you can actually, the first time you see the quiz, try it like if it's a real exam. Give yourself 90 minutes. It's 90 minutes for 60 questions. And just scroll through the questions and do it like an exam. So, sorry? Yeah, unlimited attempts. Because at the end, you can actually see all the answers and then gauge what you want to do. But what some people do, well, yeah, as much as somebody could say, okay, I finished the quiz, give me all the answers and I give it to somebody else. I'm not going to help anybody to do it. Right? Because if you're like, oh yeah, great, I get the answers, you're going to make me do well in quiz, practice quiz, but it ain't going to help me in the actual exam. So take your 90 minutes and then practice that. So if you're like, I don't know where the best place to do it, but once you have internet access and access to my internet is fast enough, you could do it in rituals or whatever. Or someplace like that, which you have an hour and a half. I think rituals might be a good place to do it because other than the noise, you can always put on headphones, run some music. You have that kind of freedom there, not the exam in lab. At least you'll have that hour and a half, nobody's going to bother you. You have your coffee and you start the exam and you finish it, right? So there's a nice little challenge, relaxing. It doesn't have to be in your home or whatever. It can be outside, but make sure you can get your hour and a half. And I'll say those places you can get your hour and a half. Much easier. So try that and see what happens. And that'll get you how good you are. Then you need to know. Then from there you know what you're missing and what you need to practice more. That's it. Right. So that's that. Group project assignments, guys. Go on the forum and put your group. So if you haven't done a group project, please form your groups. Right. Or else anybody remaining, I'll just have to start around and reassign. Give you guys the freedom of forming groups. Members of 3. Please go on and start forming groups. Alright? And when you're done, just post up on the forum your group name and your members, list of your members. And I'm gonna compile those together, and then that's what we're looking at, right? Alright, so see you guys are doing that, right? Okay, so let's I think it's now 5 past. Okay, so this is gonna be hopefully quick. In terms of IPv6, this is the neighbor discovery protocol, and different things happening in there. It's really interesting to see this piece, and I think that is what was causing some problems in our GNS tree, where we had to end up setting the timeout value to a large value over a second, because it seems that neighbor discovery stuff is happening there. And if you guys do the Wireshark analyzer, you'll notice that you're seeing a whole bunch of these as neighbor solicitation going out, neighbor advertisements going out, and it seems that has to happen first while the back pinging is happening, which I find is ridiculous, but you see, that's how that's probably IPv6 in terms of there's no router in there to say, okay, I am the router or default gateway. And this is where the problem is. I think it seems what you guys could do is, this is GNS tree, try to packet tracer, which I doubt, because packet tracer was doing a good job of it, it was working. But what you could do with GNS tree, and I think that would be later on, you could, or not later on, put a router in there and set IPv6 addresses on it and let that link up to your VLANs. Just to link up and see if the pings are going to be that same problem. I'm suspecting the pings will drop and will start to be more performance, because it's going to a router solicitation of who is the gateway. It'll find it, and then it'll allow the pings. We'll say, okay, well, I find it, I don't have to worry about you, I just want to help the ping. So I'm thinking it's something with the router solicitation that's causing it to take so long and then time. So then we just have to tell the ICMP protocol to wait long. So that's what ends up solving that problem. So we'll see how it goes. All right, so let's move. Right, troubleshoot various static routes. Not here, but what we're looking at with a fast quick quiz, the neighbor discovery protocol. Right, this reaches further than the standard ICMP v4. Right, pulling in functions already done by ICMP before and other miscellaneous protocols. Example, you have a case of ARP as a separate protocol to IPv4. ARP is actually a protocol that runs by itself. With IPv6, the neighbor discovery protocol (NDP), they are part of ICMPv6. They perform the same functions. This is the RFC for it. Now, this is the funny thing about it. And that is where all these things are coming together, and that is causing a delay. We will see. Because the switches were supposed to, or the PCs were supposed to do its own NDP, send it out, find out who the other neighbors are, and then send the ICMPv6 across, and that's it, you're done. But something is causing a delay, and when you Wireshark, we will check. So like I said, put the route in between, let's see. With NDP, the word neighbor refers to devices to be on the same data link. For example, same VLAN, which is what we reach right now, right? So that's why it's good that we reach this point. We know how to create VLANs in v4, and we're going to try. There's where the assignment comes in. It's going to do VLANs in v6, and that is where this identity comes in. So every single VLAN you guys did, even if you have all the switches connected, and you separate your VLANs, everybody's one. At the end, the protocol is only in that VLAN, and that VLAN. That's what's going to happen. As a matter of fact, if we do routing in between, neighbors protocol will still be in that VLAN. Routers will block beyond that. The NDP will block at the router level. It wouldn't allow that to go to the next VLAN. So it will stay within that VLAN. You get a concept there. So you see how that goes. Right, you have neighbor MAC discovery. Learns hosts will learn to learn MAC addresses. All the hosts, he replaces the IPv4's ARP. So ARP itself is its own protocol. But they replace that and they put it as part of the IPv6 suite. So good and a bad thing. The good thing is that, well, hey, you don't just have IPv6 and it has all these nice things, features, sets, and bad things now. It's relying on all these feature sets to work properly for you to go and have a properly IPv6 network, which is what we're seeing problems with, right? So we actually seen a negative of IPv6 at this point, because you guys set it up in IPv4, it was playing nice, and all of a sudden you do IPv6 and everything just hanging out. Alright? So this is the difference. You see real world kind of, I think it's close to real world. I think maybe really get some devices and set up the equipment. I think I'll write that down myself. Where I will do IPv6 and Linux. We're going to simulate the same setup like what we do, not in a full assignment, maybe one, 2 or 3 switches, put them together, and actually see without a router to see if we're going to have the same timeout happening here on the real equipment versus the GNS tree. But GNS tree is supposed to be real things. It's iOS, so now we're going to go to the real hardware and see what happens. Right? So you have packages of simulation, GNS tree is emulation, if you want to call it that, and then you have the real world event test that. So you have 3 different ways. Right, 3 available routers in the same time. So look at this. So using the same method as router discovery, and that is what I'm suspecting. And that's what I'm suspecting is happening here. We're not trying to do router discovery. So what's going on. Right, the Slack, right, stateless. This is a stateless address of the configuration. Just zoom high up, guys. Right, the host uses NDP messages to learn the subnet prefix. Use something like plus prefix line. So we see. And as you find, we set static IPv6 addresses on devices, and something like this Slack is happening, but that's where the Wireshark comes in. We don't monitor and see why. All of this is delayed. Then, of course, the duplicate address detection, that's the next thing. Use the NAV to form all of this. So, I think I don't know if there's a combination of all of these, but for those who want to, when they finish, submit the assignment and get done, maybe we can delve into it later on and see why you will getting some of these delays and timeouts. Why we getting over maybe a second before we get ICM to respond. So it could be a combination of all of these slowing down or causing delays in this. But we have to test it out. So again, like I said, testing, I want to take the assignment to one, take a piece of it and then implement it in equipment in the lab, in devices and stuff, so that we can actually see if that problem we see in assignment is happening in the real world. Right, so again, this is a short lecture. I might be finishing shortly in this, so it might be done shortly. Right, so, right, NAP repairs neighbor solicitation messages, NS, acts like an request, asking the host for a particular unicast, address to send back a reply, and that's why I love about this, and this is explained in the assignment, is that when you do your Wireshark, if you take a look at the forum post that I did in I have a screenshot of the Wireshark, you would have looked and you'll see some RS. I think it's some RS in there. I think it's RS and NS coming up. So you're actually seeing responses happening, and you're actually getting a reply. The ICMP reply is coming all the way after the end, and there's a whole delay. So then you have that part. Then you have the advertisement messages. Acts like an reply listing the person's MAC address. So instead of the back and forth broadcasts, you have these now. In the world of IPv6, there's no such thing as broadcast anymore. It's now multicast. Multicast is basically, well, more than one device. A broadcast is to everybody, doesn't matter. But multicast, you can control which devices you want to send. So you could actually have multicasts to routers and multicasts to like NPCs. And what you do is receive the multicast packets. And then I think it's multicast to all. So even though it's to all, it's still called a multicast. So that's one thing about IPv6. Right, so neighbor solicitation. Ask the host which particular address to reply. With a neighbor advertising message that this is not address, and then advertisement direct sent it in node. So it's the target address, so just go through it, then you have the last 6 digits and stuff to generate the addresses. Right, so this is where the multicast comes really cool. Because you look at the last 6 digits and matches the address that's being queried, so it's not specific. It's not like a broadcast going back to everything, it's with the specific devices going back, which is where it comes. Advertisement, this is standard IPs. Letters send reply to neighbor solicitation, and unicast send back to the original neighbor solicitation message, and the host can also send an answer with any announcement. Alright, so this is interesting. This is the closest you can get to the broadcast as this one here, but it's a multicast address. Right, so if you send it to this address here, ff02:1, that's going to go to, it's a multicast all. So this is the closest you get to like a broadcast. I know when you switch broadcast is basically all Fs. It's sent to that frame, destination frame, it's the all Fs, and switch is going to send it to all. Or if you're not ready to switch, the switch is going to just broadcast anyhow, but that frame is going to go to all pieces. And all pieces are going to receive it and try to do the process. Right, so this is an example here. You have this learning map address, right? Yeah, I think it's almost like IP learning map, right? Using that neighbor solicitation, learning map must be another message. This target unicast address. When you apply, what's your link address? This responds back to the original host asking this link address coming back, right? So that's solicitation and then the advertisement coming back in, right? So LS and then any. Right, so yes, and I'm thinking again in assignment, this is where you're starting to have this problem coming up where the delay is happening because you're trying to take, but a lot of these neighbor solicitation addresses are going out, and if you do the Wireshark, you're going to see it. Wireshark is picking that up and showing a whole bunch of NSs going out, or something like that, or RFs throughout the solicitation coming out, and then after all of that is done. And then it's when somebody's going to end up responding and give you the MAC address. I suspect that it works. Like, let's say you pick it up once, and it takes a while, and then if you try it again, it might work, but sometimes it just you see it over and over. Which I find very weird. I don't know why it's doing that. Sometimes I did try it, and it actually worked awfully bad. I'm getting a delay of maybe 10 milliseconds, really small. But in this example, everybody here, we're getting over 1,000 milliseconds. So that's something to check. Right? Did I? Right. So it sends it matching node value control of this. Only most that just ends with 0002. Right, so that one I'm not so sure what. Right? Right, so this and then this address, this is a MAC address thing. We'll listen for this node multicast address. And only a small sum of 2 for process to receive NDP message. Right? I think it's let's see. Yeah. Doesn't match up really much. Alright, well, let's see. That's from the text. So right, so neighbor advertisement, this is the MAC address, and then after that, the neighbor table. Just go through that fast, right? Right, so we have the neighbor IPv6 neighbor table router R3. So routers also have neighbor tables with respect to the host is connecting to. So this example here, we have has the MAC address of our router R1's WAN link interface. So that's this area here. Come on. Right, wrong place. Right, so it's at this one, it's learning MAC address, both it's global unicast as well as the local, the link local on the same interface. Right, so you'll notice, let me just try it right. This is it here, the FAAT, right, is the link local address. And like I said, straight off, that's why I tell you I rather use a global unicast or maybe a local unicast address for my my device. Because this FE80, that's all well and good, but I can't control its value. It's going to have to change, and sometimes if you try to set it, the device might not accept certain one. So sometimes I do try to set a link local, it doesn't work. So you have to go to not a global unicast, but you have to go to like a local unicast address. So it wouldn't be 2001, they're different value. 2000 and 3000 series are global unicast, that's everywhere the internet uses it. But other values, I think it's F02. I remember, I think it's F02. F02 is where you have the local unicast. Right, so this is the thing about it. Show IPv6 neighbors, and when we go to the router, you can check that out. You'll learn that. Right, to view the neighbors, the host's neighbor table, you can do the Windows Linux IPv6 neighbor show and then MVP-am. And I think show IPv6 address, IPv6 neighbors, right, for all these. So you have all the platforms kind of covered here. That's really, this is like basically I think it's basically ARP-A. So the IPv4 equivalent would be ARP-A, and it's showing all the mappings between the MAC address to the V4 then with ARP, but this is case with V6. Right, so there we go. Discover routers with NDP-RS, router solution and router advertisement. So this is where we start to get problems when you Wireshark 2 showing up a lot of the RS coming out there. Right, it uses the concept of IPv4 default gateway or default router. So we would have, and this thing is done with two ways we do this. Is either we manually set it, or we use the dynamic host configuration protocol or DHCP server. I'm hoping to try that your free group project. You will have to maybe set up a DHCP server to lease out IPv4 and v6. DNS with IPv6 that tested from DNS3 does not work so well. So I'm not going to do DNS with IPv6. You can do DNS with v4, it will look relevant, but not with v6. It's giving some issues. I'm not so sure why. Either it's a router or something with the protocol. It's not doing so well. So, or it could just be the whole delay. But anyhow, so there are two ways for your PC. You could set it manually, and you would have seen in the labs, you actually have to see the IP address and gateway set manually. Or you do it set automatically by the HTTP server. In the one course, I showed something called DHCP relay, so it's not covered here. That's covered in one course, so you guys can read up about it. You don't have to do it for the LAN in terms of the group project. It's not required, but something that you could check it out and look at it, right? The DHCP relay is pretty cool because in the one course for the group project, they had one DHCP server, and that was providing IPv4 addresses for about 3 or 4 different networks. And that was across a whole long set of links. It was really cool. Because the server was like on one side of the network, and then like about 20 around something routers in between, and then about 3 or 4 PCs or groups of PCs on the other side. And they were getting these IP addresses from the router on the other side, which is really cool because that tells you that you can have it in one place, and you literally can have a whole, you can actually do DHCP off the internet then, basically. You could set one across on one side of the internet, and then you can actually send IPv4 leases to clients on another network. Right? Of course, not a good idea because other people might want to get if they know your router is a DHCP relay, they'll want to use it to get IPv4 addresses. But it wouldn't work because if they get the IPv4 address, it's going to be the wrong network they want anyhow. So they might get it. They'll be in the wrong network, and then they just can't get to the internet because they'll get the wrong gateway, wrong IP, wrong gateway, and the router they're on with. They'll just say, okay, well, I can't allow you through because you're not matching up. Right? Your network is not matching up with my default gateway. So that's why it could work, and they don't have a problem. Right? Use the same concept of default gateway, so that's the thing, but it improves better for hosted mainly than it possible default. So this is where the question I say improves, I'm going to put a question here, improves, if it's really improves, of possible default gateways using NDP and the RS and the RA. Right, so it's going to do that, and this is what was happening in the assignments when you look at it. So that's what was supposed to be. So I'm thinking it doesn't really do a good job because we don't have any routers in the assignment configuration at one. All you just have is layer switches. There's no routing setup, so they're trying to look for using the NDP, looking for RS and using the RS and RA protocols, and it's not nobody's responding. That may be delaying it, but we have to try it on real equipment and repeat it. So I'm going to call that a kind of limitation or caveat of IPv6. Right, 2 messages for the server routers. You have the router solicitation RS. Right, this is sent to all IPv6 routers. right? Local scope multicast address, so they actually use a FF02, right? So that the messages ask all routers in the local link to identify themselves. Again, that is sent out on the link, and then again, like I said, the Wireshark will pick this up, right? And then after that is router advertisement, which is router response, right? Of course, that's the thing. In our case, we don't have any routers to respond, so they will not get back this. You might just keep getting more RS going on, and no more advertising response, right? Sent by the router, list many facts, including local link address of the router. When it's sent, it flows back either to the unicast of the host or to all IPv6 using the FF02:1 multicast address. All right? It also sends it without being asked, and it also sends the FF02 multicast address. So that's fine. The problem is that without a router, you may be getting all these performance problems in terms of devices coming on. Maybe, not for sure why. So this basically is saying that the router can actually, you want to find what's the default gateway? Yes, the default gateway. Now, this is the thing about it. They can actually do that because the router does not necessarily need to have an IPv6 address matching up your devices. What they're doing is that the router sends the link to local address to you as a default gateway. So when you want to get out to the internet, you don't say, hey, I want to connect to 2001 stuff as my default gateway. No, I connect to an FE80 whatever it is as the default gateway. And it will work. That's how the IPv6 will work, and that's how you can get out in the country easy. And the advantage now, that's the reason why you have IPv6 global unicast addresses, so that the packet could come back to you. Right? So you can actually don't even need to know what's the route IPv6 address, and that should be able to get out to the internet and can come back in. So there's something you guys can try out as well in the group projects. Right, these are just simple screenshots, not a problem. If you learn your link local address, so you can see what's happening here. It's the link local. Asking Aaron to reply, and this is it. It's an FE80 link local is going back. So they didn't show it here, but the PC can actually have 2001 or cafe, whatever IPv6 address. But it doesn't need to know what is the router zone. The router is going to reply with this link local, and that's it. The thing about it is that you ask as well, okay, would that be the same network as me? The PC will also have a link local address with an FE80 : whatever is file, this and that. So because of that, that FE80 is going to be on the same, like say, broadcast network or broadcast VLAN, and be able to communicate and reply. All right, I think right? It doesn't use broadcast. Like I said, IPv6 does not use broadcast, it uses multicast. Right? It flows to all router multicast addresses, and this is basically, this broadcasting, basically multicast backhaul. So message can flow to either the unicast of the PC or to everybody. Same thing as like the neighbor solicitation. All right, so you have something called Slack. So it's a stateless process. So for me personally, Slack is good depending on the network design. But for me personally, I would rather use HTTP straight off and create releases for my clients than to use Slack. Slack is nice to have when you have another network. You don't have too much management. Slack is perfect for a wireless network. A lot of if we decide to go IPv6, which is the plan, for wireless, we might put everybody on the wireless IPv6, but we're going to use Slack as the main method to get for everybody to get IPv6 addresses. Right? So it's not we don't have to say, okay, this is the block. We just say, okay, this is the main prefix block you're going to get, and then we're going to let Slack do what is the actual device, what is the actual IPs afterward. For that method is good because once we get the releases out, we still log that. We'll know who owns it. We will find out who's the MAC address, and we will know who owns it, and then we could actually log that. So if anything happened and already decided to do any site kind of cybercrime kind of thing or anything unsavory online, and has been tracked to that IPv6 address, then we can actually map it to the MAC address at that point in time. And once you have the MAC address, so then we can trace out where you guys are going across the campus. Or for that matter, just block it off the entire network, so you can't connect to the campus network at all. So we could do that. So that's a good thing about it. So even though you think you have this kind of freedom, yes, this will monitor you on the enterprise network, you do have the monitoring and stuff. Right? So both supported. Now this is the interesting thing. So to find an address, I'm just going through a little bit about this. So find an address with the HTTP, it sends a message to the server, and the server sends a currently unused address in the correct subnet for the endpoint host to use. So the main thing is the correct subnet that the host is in, so that they can use it and communicate with other hosts. That's the main thing. And that's what they will use. The process relies on the client functions in each device, and the server configured and working in the network. Now, this is the thing about it. All right, let me just go to Slack and see. Let me see where we go to Slack, right? Right, it supports a method for hosts, right? So we know first. All right, let me go back. So, without DHCP and IPv4 network, when a client connects to a network, have you ever had that problem before? You connect your internet network and then you're getting a 169.254 something like IPv4 address. You ever see that happen, right? So that's actually a private block that is kind of Microsoft, like Microsoft uses that block for their PCs. Linux doesn't do that. They just don't get an IP if it can't find out. So it wouldn't establish to get an IP. But Microsoft did that, so it was cool because we tried that years ago and say, hey, plug all PCs in here. We don't need a DHCP server. Everybody will get a 169.254 address, and they'll all be it's a /16, so everybody will be able to see one another. And then PCs will communicate broadcast-wise to make sure they don't have any network conflicts, IPv4 address conflicts, which were problems that the network that we were doing had about 5 or 6 different switches along the way, and the broadcast was taking a while. And the thing about it that some PCs was communicating, others weren't, and it was just a mess. That was basically doing a LAN party in essence. That was what it was. So we had like about the already SSC offices upstairs on the opposite from Juman's, that side. They had like open areas. Well, actually, they still have the rooms there. Upstairs, SSC. When you go upstairs, SSC, instead of going left by Juman's, by the stairs, so as if you're coming from like Trent Road, you're going right, and then down the corridor, they have offices on the left, and then some rooms on the right for clubs and stuff like that. So they had they would have like a whole area where we were doing like a LAN party and set up computers all over, with plugging and switches and all that stuff. I don't think we threw any breakers, but the network didn't work out too well. So I think it was the cabling was wrong and the troubleshooting was problems. Eventually ended up having segmented networks, even though they're connected. It was a real hope. But in the end, it still worked out with some things. I think it was StarCraft, what's the name? Yeah. So the thing about it is that a DHCP server was required to kind of help with it, and we could have troubleshooted with that better, because a DHCP server, we know you're the one to give out IPv4 addresses to everyone, right? And as I was telling in this campus, every single subnet we have here, most of our subnets, particularly big networks, like with clients like PCs in a lab or staff computers or even wireless, we have a DHCP server leasing out these IPv4 addresses. And the thing about it is, if we don't have a DHCP server, you don't get an IPv4 address, you don't get a gateway, and to go to the internet, no network, you have no access to the internet. So it's really cool to see that sometimes a power failure happens, the server goes down, doesn't come back up, and everybody say they have no internet. Internet is a problem. But when you have to do your diagnostic checks and realize, wait a minute, the internet is working, it's just these clients are not receiving an IPv4 address. So the problem could be related to the server. And that's the thing about it. And you guys can Google it right now. There's no Microsoft trial thing, I think it's IPAM, IP Address Management or something. You can search for that. They did something with some IPv4 load balancing servers. So if one server failed, the other one automatically kicks in. The problem is they have to synchronize the releases from one server to the other server, and that's the problem. So Linux trial thing, I think DHCPD IP what do you call it? DHCPD is in Linux, and I think it's DNS mask is the other Linux-based DHCP server. Again, they don't do proper load balancing or failover of DHCP servers. You can Google it, check it, it doesn't exist. So that's a nice area to get into, to build the protocol or build the software that can do it. Right? Because that's the problem I had, and I actually tried to make something with Linux, with scripting. It worked. It just to maintain it was no problem. So you want to build something that once working, and then that's it. You have that synchronized between one another. If one fails, the other one is going to continue with as if network, nothing changing network. So that's the idea. But why I'm digressing all of that to show that that's a limitation of IPv4 and DHCP. IPv6, they try to solve this problem using something called Slack, right? Which is stateless address auto configuration, right? So it supports an alternative method, right? So choose an unused and does not require a server like a DHCP server. So they're saying, hey, you know what? Guess what, guys? We don't need a DHCP server. They just said, oh, okay, we don't need one. Okay, that's great. I don't mind. Right? It uses a simple three-step process. Begins by learning the prefix length, using the link from any router. So then it has what? It has to use the neighbor discovery protocol. So you realize a lot of protocols in IPv6 happening here that has to get first Slack to work, and they're taking advantage. Slack is taking advantage of those things for this to work. So once it does this, with the NDPRs, it'll learn about the router's IPv6 addresses. So it'll learn all of that. It builds an address from the prefix plus an interface ID. So it's using the interface ID. First one, I'm using the UI64 rules or as a random value. In Cisco exams, sometimes they bring up UI64. I'm not going to go into detail in here. You guys can read up on that. But UI64 is actually taking the MAC address of the PC or the client. It's going to take a MAC address and do some manipulation, some bits on it, and actually create an IPv6 address from Slack. So it's going to take the primary prefix plus the interface ID. And that's what it's going to generate with this UI64. So you can actually set a Slack address by typing IPv6 auto and then UI64. And it should be able to generate this for you. So you normally put the IPv6 address, :/54, space, UI-64, and it should generate it using this method. Right, of course, the UAE address, it now uses the duplicate address detection, DAD, to make sure that no other host is generally using the same address. So IP4 does that, and 6 will do that as well. So this is good, and this is the alternative to have. But the problem with this now is that you now don't know who has an IPv6 address, right? If we apply this method in our campus wireless network, you guys will use Slack, all well and good, but there's no monitoring to show who has this address or not. So this may not do, because this requires multicast on that network. Our wireless is not allowing broadcast, it's not allowing multicast. So IPv6 via Slack, security-wise, is not going to work. So there is a limitation of using this. It's nice and well for like maybe a computer lab, or not even a computer lab. I think it's more like an area where you want to get more like an events place. You want to get people up and running fast, use this. But if you want to maintain and have logs and security and stuff like that, you will not want to use this. You want to actually use a real IPv6 DHCP server. Release the IPv6 addresses to you. It will map it. It will keep a log of who gets it, and that's it. So it wouldn't be anonymous. So this is close to like anonymous and getting an IP and going out there. But in this network, we don't want to do that. All right. So that's the limitations of, you could say, of using Slack. Right, so this is just a process of the using Slack. It's 3-step. Come on, learn the prefix link, using a link from any router, using these messages, right? Build an address from the prefix plus an interface ID. Choose my either using this one or random value. So the interface ID, this is most cases a MAC address plus others. That's what it will use for the interface ID, and that's how it end up generating the IPv6 address for the device, which kind of makes sense because it matches it with any prefix, right? Remember the prefix is / whatever, so this could be a /. Where's my, all right. it could be a /64, right? And guess what? MAC addresses are 48 bits, so you have 48 bits as MAC addresses, and then you could still have an extra 12, I think. Not 12, yeah, 14 or so. Yeah, I think 14 more bits that can be used. Actually, no, how much is 64? Yeah, I think it's 14. From 48 to, let's see, 14 plus 16 is what? 64? Oh, yeah, sorry, yeah, 16 more bits. So 16 more bits will get you, will make your foot. So you have 48 for the MAC, and then you have the 16 again, so you can have more space. Right, just skim through this, not so much. Right, so it uses duplicate address detection. It is part of the SLAC process. SIP does not use it until the problem is resolved. Even with the HCP, same thing. It will not assign it, it will just assign it to the next one on the list. So I ain't going too much of this. I don't go too much of this either. Right. Right, so this is some examples of duplicate address. Well, I'm going to go through this either as well. So you see duplicate addresses here, duplicate addresses here. Node is a neighbor solicitation, but must be a duplicate, so it's sending a neighbor solicitation, this example. And this PC2 is responding with a neighbor advertisement back and saying, hey, this is my MAC and this is my IPv6 address, right? So it must be a duplicate. And yeah, so that's basically one, right? 1, 2 reply, yeah, send reply must be a duplicate. So this one, so what's happening here? So the question really is who's going to decide not to use the address, right? So most like PC1, because of that, it's send a request to see who has one, and somebody responded matching with me, I might have the PC1 might end up changing his address. Right, duplicate address exists. Yeah, it's all well nice to say duplicate address exists, but we have to solve this, right? So it might have to actually not use it and then use another one. So it's how to resolve this. So it's cool, it's great, but you need to resolve this, right? Come on, wrong spelling. Yeah. Right, how to resolve it, that's what you need to do, is most likely not to use it. Right, so just summarize the discovery. So this is important in terms of, like, sometimes the CCN exams will come up with some of this, so I'll tell you. Right, so you have router discovery, router solicitation or advertisement. Who does it? Who discovers info? Any host who supplies it, the router. And then info supplied link local IPv6 of a router. You have prefix length, you have router solution advertisement, same thing. Right? Neighbor discovery, neighbor solicitation, and advertisement. Right? Who does the host and link layer? For example, MAC address used by neighbor. Now, in this case, this is MAC address as an example, but link layer could actually be other layer 2 stuff. We know a MAC address more associated with Ethernet. Wireless might be similar. You use MAC addresses as well. So wireless and Ethernet is about the same in terms of MAC addresses, but that's the most popular right now. It's very hard to get like other protocols, layer 2 protocols to work with. Right? Duplicate address detection. Well, that's between PC. Simple, whether even passes already into. So that's it. But it's up to the PC now to reject and use another one. Right? So that's more or less it. This summarizes what we did here, and as you know this. Right, so we have some minutes here, but I guess you guys could. Oh, any questions for the assignment or for the exam next week? No? No questions? Anybody had good questions? Somebody had something in the forum there? Well, actually, they emailed me. So they said that they couldn't ping the devices. They tried to ping it this weekend, so I told them just restart the device, save and restart each node, and sometimes that will solve the problem. What they said is that having all running on the device wasn't working. You had to end up shutting down some for it to work. So just put that in your notes or something in document to say that that's what you have to end up doing to troubleshoot. So I'll least put that in there, so I can advise them after that. That's what they have to do. Right, so that's that. The line is not fixed, so you guys can submit later. The longer you take, you're going to take into the exam, right? You have a quiz, a sample quiz you guys can try out. It's not all the topics, so it's just for you to get an idea how it works. And most of the questions, all the questions are actually valid questions. It actually be a subset of what you will get in the coursework exam. But it's not an exhaustive list of the topics. So all of the valid questions. So you're going to get some of those in the coursework exam. So you should be good. Right? So that'll be next Saturday. See you guys there. But I'll see you guys this Saturday for the lab. Right? The lab is basically IPv6 routing. And so remember we're wrapping up IPv6 and routing. This is basic static routing IPv6. That's this week. Next week we're going to deal with RIP, Routing Information Protocol, and then EIGRP, and what I think is, I'll see which one, OSPF or EIGRP, doesn't matter which order. And all of during that time is where the group project topics will be going on. Oh, group projects, guys, just put your group project information, like who your members are, and put it on the forum, right? Because you need to get, I need to get who is it. I mean, you're given the freedom to create your groups, and you do that. Those who have not created groups, just let me know and I'll gather randomly assign. Or I might just tell me if you can't find a group, and I'll just put you in a pool and then randomly create. And who knows, maybe actually you'll better gelling and working together as well. So that could work too. Right, so that'll be where I reach. So, all right, folks, that's it. And see you guys on Saturday, right? Have a good evening. All right, bye everybody. Yeah. All right. Yeah. All right.